So I just recorded this whole thing with the GoPro on my head so that it was just the view of what I was looking at. I had both hands and it was out of focus. I've never seen the GoPro record without being in focus. I don't know. So we're going to do this again, but not the full way because it takes a while. So I'm going to go through basically the motions of what you would have done for Lab 13 so that you can complete the lab. So this is about mark recapture. You have this handout on Brightspace. So mark recapture is just one way that wildlife biologists can estimate the populations of animals. Knowing the number of animals in a designated study area is interesting, but we also have to think about the ecological population and how it's defined in terms of the interactions among organisms of the same species and not just our convenience. So we have to define what our individual is, usually a species, and then also just establish the limits of the population we want to count, because that's going to help us determine what kind of counting method. So for instance, Arctic and prairie habitats, so those that are really open, those lend themselves really well to aerial methods, like going in a helicopter. But you wouldn't want to use that in an area like a forest or at night or underwater. And then if the animals can be collected or observed in a standard time or collecting effort, we can get an idea of relative abundance, but not absolute numbers. Remember, we're not counting every single individual. So for example, the number of grasshoppers that we collect in 50 swings of an insect net through a field produces data that we can then use to compare as a relative abundance to other fields that are of similar habitat. But it's not going to tell you the exact number of grasshoppers. So for estimates of absolute numbers, mark recapture can be very effective. Remember, these are estimates. So we first have to capture and mark a sample of individuals. And marking methods depend on the species. So birds, you can use those bands around the legs. Snails, you can mark with waterproof paint on their shells. Butterflies get little stickers on their wings. Large mammals, you might use collars, radio collars. There's a table on the next page that has some more common types of marking methods. So you have to mark these animals and then immediately release them as close as possible to where you collected them. And then you have to give them an amount of time to adequately kind of mix back into the population so that you go out and do a second trip where you do another sample. And the size of the population you then estimate from that number of marked individuals you captured on that second event. So the assumption behind mark recapture is that the proportion of marked individuals recaptured that second event represents the proportion of marked individuals in the population as a whole. So you think of it this way. Big R is the animals recaptured on the second event that are marked. Little n, sorry, this was a typo, little n is the total number of animals that you recaptured on that second event. So number marked out of the total equals the total number of animals that were marked and released out of the total population size. See how they're proportions. If you rewrite that so that you're solving for the big N, population size, you just get this. So now if you see the smaller the number of recaptures, that big R, the larger the N's going to be, right? And the bigger the number of recaptures, the smaller the N's going to be. So this makes sense because if the population is really large, the marked animals that you release into the wild will mix into a greater number of unmarked animals. So the recapture probability of getting them the second time is lower. So for example, if you visit a cypress swamp and capture 100 individuals of a particular species of box turtle, mark them with red paint on their shell and release them, go back a week later and capture 120 individuals of the same species. Of those, 20 of them have your red paint. So then you can put that into this equation. So you're solving for N. You captured and marked 100 different individuals the first time you went. You went back out the second time and caught a total of 120. And of those, 20 of them were marked, which gives you 600 potentially is the population of box turtles. This is called the Lincoln-Peterson method. It's very simple. It's fairly straightforward, but it depends on these assumptions. If you violate the assumptions, it's going to affect the accuracy of your estimate. So you have to think about that. The assumptions are individuals with marks have the same probability of survival as other members of the population. That plays into what kind of marking method that you're going to pick. It can't harm your animal. It can't make your animal more more obvious to predators. That's going to think about how that would affect your population size. I'm not going to name them all because it'll take so long, so you can read this. Second assumption is that births and deaths don't occur in significant numbers between the time that you released your marked individuals and the time you went back and recaptured them. And then you can read why. How would that affect the population number estimate? Assumption 3. Immigration and emigration don't occur in significant numbers between the time of release and the time of capture. If the marked individuals leave the area and a bunch of unmarked ones come in, what's going to happen? What about the other way? Assumption number 4. Marked individuals mix randomly with the population at large. If your marked turtles don't move among the unmarked turtles and you recapture them basically at the same place you released them, then you're going to have an overrepresented number of recaptured turtles. It's going to drive down your population estimate. Assumption 5. Marked animals aren't easier or harder to capture a second time. This is trap happy or trap shy. Trap happy means, oh, I figured out I can get a free meal. I'm going to come in there a bunch. Or trap shy. Oh my gosh, it was terrible when you caught me and you put this thing in my ear and I ran off. I'm never going in another trap again. How is that going to affect your population estimate? And last, that your marks don't come off. If you pick a type of mark that might come off between the time that you mark them and you go back out to sample again, that's going to affect your population estimate. So even when recapture rates are high enough to support a good accurate estimate, the Lincoln-Peterson still tends to overestimate population size, especially when you get really low recaptures. There's a better estimate that some will use instead called the Schnabel index. Here's its equation. Don't let it scare you. Population size. The sum of M times C divided by the sum of R. So you're going to take multiple measurements of these and then sum them. So M is that total number of previously marked animals at a particular time. So time is just your different events. So your total number of marked. And C is your number of animals you caught. So total number of animals you caught at time I, which is your events. And then R is the number of marked individuals at that event, that time I. So for example, we go out and we mark 100 animals. That is your total number of animals you caught. There's none marked yet because you haven't done it yet, 0. So your new marked is 100. And your total number of previously marked animals is 0 because you hadn't done that yet. First time you went, caught 100, marked them. You go back out at the second event and you capture 85 individuals. You caught 85 total. 15 of those were marked, so you had to mark 70 of them. Now this M is the total number of previously marked animals. So in this case, you've only been out once, so it was 100. So I pointed the arrow. Then you go out a third time. You catch a total of 105 individuals. 25 of them were marked. So you would have to mark, 80 of them, but you don't have to write it down in this case because you're not going out a fourth time, but it would be 80, sorry. And then your total number of previously marked individuals is just this column, all the past ones. So 170. So that's why pointing out M at time 1 is 0 because you haven't marked any yet. And then because that is the sum, that E symbol, you would do M sub 1 times C sub 1 plus M2 C2 plus M3 times C3 divided by R1 plus R2 plus R3 to give you your population estimate. Now note that if we'd only done 2 samples, didn't go out to that third one, our population estimate would have been 567. That's a really big difference between those two numbers, right? 567 or 659. So number of sampling efforts really comes into play. So this is the part I'm not redoing because it took forever. And I'm sorry my GoPro didn't work, but this would be the part that y'all would have done in lab. So you have a container that had 400 beads. They were all of this color, which is the same animal. I realize they're technically different colors, but there wasn't enough of all the beads. But all of the yellowish beads, whatever, were all the same species of animal. There were 400 of them in here. The first thing I did was took a sample with my little beaker. I don't really have a beaker, but I took a sample. I dipped that in there. I took a sample. Ignore the black ones because I had already finished it, but they were all white when I started. And that was my very first sample, which was, I think it was this one. So over here, I counted those up and there were 91 of them. And I realize this is the table for Schnabel, but you can get the numbers that you need for the Lincoln Peterson. This is where you're going to do Lincoln Peterson. So you went out and marked, caught, and released 91 animals. See? M for Lincoln Peterson is the same thing as C1. We're just putting them all in the same table. That way you don't have to repeat that first event. You don't need the 0 because you haven't marked, none of them were marked yet, right? So you marked all 91 of those. And then they don't go back in because we marked them by replacing them with the dark color. So all 91 of those went back in here. I shook it up really, really, really well. And then I went back and I sampled it a second time, dumped it out, and I counted, I think it was this stack. And what I counted, was that 18 of them had marks. So I had to mark 80 of them by making them the dark color. If you add those two numbers together, it's because I caught 98 total. I caught 98 total. 80 of them were yellow and 18 were black. So now that's all you need to do Lincoln Peterson, which is what you're going to do here. Here's the equation. You are going to solve for N. You caught 91 total animals. How many total did you capture on your second event? Hint. How many of those on your second event were marked? Hint. Complete that equation here so that you write down what you got for N. Show your work. Don't just write the number. But then we had to keep going to get the rest of the numbers. So we've done it the second time. So now I went back in. I put these 18 back in, and I put 80 black ones in. So all 98 individuals went home, but 80 of them were marked now. And then I went and I scooped another scoop and dumped it out. I don't remember which one it is now, and I counted up how many were the yellow and how many were the black. What I got was that 45 of them were black. So I had to mark 57 of them. How many did I catch total? You tell me, add them together. How many have been marked previously? Remember, that's all these columns before. So here it was just that one. For here, it's going to be this one and this one. I've got arrows pointing to them. You fill that in. And then the 45 that were marked and the new 57 that got marked that were black got thrown back in there. I shook it up really, really well. And I did one last scoop, dumped it out, and counted up how many were yellow and how many were black. 55 of them were marked. They were black. So 47 of them weren't. Technically, you don't need that number there because we're not doing a fourth one, but you can write it there if it helps you, because total that you caught in that scoop was the 47 plus the 55. You write that in. You tell me what that number is. You add it up. And then the totals that were marked in previous events is that plus that plus that. You write it in. I want to see this table completed with complete numbers. I've given you everything you need. So take a good look. And then you'll use those numbers to calculate the Schnabel. I've even rewritten the equation for you. Remember, it's sums. So M1 times C1 plus M2 times C2 plus M3 times C3 divided by R1 plus R2 plus R3. You write it out, you calculate it. Don't just write a number. Now remember, we started with 400 beads. So then you're going to answer these questions. How do your estimates compare to the true population size? Did you get better estimates with Lincoln Peterson or Schnabel? If you got 408 for one of them and 409 for the other one, don't tell me that, oh, the one with 409 was better. No. If you get 510 for one of them and 406 for the other one, well, yes, one of them was better. So if they're really close in number, don't just tell me one of them was better because it was higher by 2 numbers. And then explain why. What do you think that means? Oh, focus. Did the Schnabel give you a better estimate than the Lincoln? Why? If it did or didn't, and why? If migration occurred in the population, how would this influence the reliability of your estimate of population size? Would your population size be too high or too low, or would you not be able to predict how the estimate would be biased? Remember, what does migration consist of? Immigration and immigration. Remember a couple pages back, it talked about what would happen if you had either one of those things occur. And then what would happen if the animal you were studying became trap happy? Remember, that means they like to go in the trap now. So you're going to catch more of them that are marked. Would that make your population estimate be high or low? It's in one of those previous pages. So all you have to turn in is this completed table, this estimate with your work, just like if you were in math class. Write it out. Tell me, write the equation and your work and the result. Same thing for Schnabel. Write it out, calculations, and the result, and then answer these 4 questions. Turn it into the Dropbox next week by 11:59 on Monday or Tuesday night, depending on what class you're in. Contact me if you have any questions.